Right. Hello, everyone. By everyone, we don't quite have that many people in yet. I think one possible reason is I'm starting half an hour earlier today as compared to the junior session yesterday. So if you know any of your friends that wanted to join but thought the time is 3 p.m., just give them a ping and let them know that we will be starting pretty soon. As I said during the junior stream yesterday, the reason for this somewhat strange timing is that I know many of you probably just took the SMO Open. Maybe you're brooding a bit about the SM Open, and we'll have the session for that at 6:30 later on. Once we have that session later on, then you can see where you went right and where things did not go quite as well. But yeah, this session is for the SMO Senior, which was yesterday. I didn't want to do it last night. And also the reason why I'm starting a bit early is that I want there to be a little bit of a break before the open session. Both for you guys, because focusing on the open paper this morning and then this review and then the open review is a lot of hours of math. Also for myself, just to be able to get a bit of a breather in between. And by breather, I mean I haven't actually solved the SMO open questions yet. I haven't actually finished looking at all of them, so I also need to solve them properly. The SMO Open is not easy, and yeah, it is a little bit scary even for me to say, hey, I'm going to do this later on, and I haven't even finished preparing the questions yet. So we'll see. Hopefully that goes well, but we are on the SMO Senior paper first for right now. Just to address the SMO Open a little bit, right? I've heard some of my students and some of you saying that SMO Open actually seemed a little bit easier. I don't think you meant easier in absolute terms, but easier relative to expectations. Like the senior felt more difficult than you would expect, and the open felt kind of maybe only as difficult as you would expect, maybe. So if that's the case, then in a sense the open felt a bit more difficult. But in absolute terms, there are still about 10 questions in the senior paper which are relatively normal, meaning that if you have understood the common ideas that recur, you can get something about 10 questions. Now, any more than that is pretty difficult to do because there is some either less well-known theorems involved or a little bit more creativity involved. And I'll talk a little bit more about that as we get there. Yeah, I see people are slowly streaming in, which is great. The first thing to note is that this session will be about 2.5 hours long. I don't think it will take 3 hours. The paper looked difficult, but as I went through it, I realized we don't really need 3 hours. But nonetheless, just feel free to relax. You've already done your job today and yesterday taking the SMO. Now it's my turn to do my work. And we'll go through all the questions as before, from the easiest question to the most difficult question. You can watch this back later on if you have to go somewhere in the middle of this. That's fine. Or if you feel that your brain's hurting too much and you just want to re-watch it later or another day to absorb better, that's also fine. Now, I think this chat usually for the senior and open sections is not as hyperactive as the junior one, but nonetheless, just keep things civil. When you have scored well, congratulations to you. If you have not scored as well, it's okay, but do not grandstand a bit too much and make people feel bad, because that's what happens when we compare scores after every SMO, right? You always feel lousy. No one has ever felt good when comparing scores, and usually the person that feels really good saying that I solved everything did not solve everything. So don't spend too much time comparing, and don't spam the chat with that. Now what you should do is let me know if I made any silly mistakes, because it can happen. Some of you have tried my mock papers and you know that I can misspeak or miswrite, because even for the papers that I set, I teach usually without referring to the notes in front of me. Now in this case, I have not actually got any notes except the questions in front of me. So even though I've roughly prepared, I may say something wrong, or I may not be as clear as I would like to. So please clarify if anything seems to be less clear than it should be. And if you think you have a better method, please share, because I will try to go over more than one method if I think they are viable, but sometimes I only thought of one and you thought of a different one, which is just as good. So please share and we all benefit. Yeah, so as usual, I'm going to focus more on the motivation, the key insights, and any unusual theorems. So for example, if we were to use something like, I don't know, the discriminant. I'm not going to explain a lot about the discriminant. If you are someone from junior watching this and you don't know what's the discriminant, then you can check it out, but that is considered standard. Now, on the other hand, if I use something like Ptolemy's theorem, I'm going to say what it is, because even though some of you know, some of you would not know what is Ptolemy's theorem. So I'm going to explain things like that. And computational steps like expansion, factorization, multiplication, and all this, I'll just move through it quickly to avoid too much boredom. It's not fun to watch someone do long multiplication. And yeah, this is the same comment as I left on the junior stream. This is not official. I'm grateful that I'm allowed to do this and have the blessing of the Singapore Math Society, but that's not an official production, which means I didn't get access to the questions in advance, and I definitely did not get access to the solutions in advance. And also a reminder that there's a second round. So if you're wondering what's the cutoff for the second round, I don't know. But if you're wondering what's the cutoff for the gold, I can tell you that it literally has not been decided yet. That depends on how the second round is. That also means that if you are, let's say, aiming for the top 30, or you're aiming for a gold, and then you hope that you could get, let's say, 19 questions, and then you realize, oops, I made 2 careless mistakes, and I got 17 questions. Or I hope to get 17, and I got a careless mistake, and I got 15. That's fine. It doesn't make a huge difference because most of the impact comes in the second round, right? And whenever I am explaining to my students for SMO round 2, I always tell them that the entire range of scores in round 1 is covered by one problem in round 2. So if you solve one more problem than everyone else, you get first place, literally. It doesn't matter exactly what you scored, unless everyone else that scored better than you also managed to get perfect scores or something really good. Yeah, so the open session, we will do the review tonight at 6:30. And that one will probably take a little bit longer than this one. So yeah, that's why I want to schedule it in the evening. Hopefully there's nothing going on tomorrow. I know some of you are going for the SIMO camp, but if you're not going for the SIMO camp, going remotely for the SIMO camp. If you're not, then yeah, you will have some hours for later tonight. Okay, so let's get straight into the problems. I think we can go through the first few questions first, because the things that a lot of your friends might be even more urgently wanting to know are the ones at the back, and so we can hopefully have a fuller attendance by that time. Okay, so question 1. Suppose the roots of x squared over 2 plus mx plus n equals to 0, m over 2 and n over 3. Find the smallest value of mn. So this is a classic question using Vieta's formulas, the sum and product of roots. In this case, the roots are m and n, and the coefficients are also m and n, or rather in terms of m and n. So you get equations that just involve m and n. No negative. For product of roots, it's just n over 1/2, which is 2n. And for sum of roots, it is negative m over 1/2. 1/2 is the coefficient of x squared. Yeah, so we have this here, sum and product of roots. And usually when I see the product like this, I want to straight away jump to, well, that can be solved. But remember that it says smallest value, and every time you see smallest value, there's just a warning that, okay, there may be more than one solution, so be careful. Now, if you want to cancel off the n, that's almost correct, except that, well, technically n equals to 0 is one case. So if n equals to 0, then that's one case. The other case is if it isn't 0 and you can cancel it out, then m would be equals to 12. Yeah, so that's the two ways in which this equation can be satisfied. Now if n equals to 0 and you put it into here, you get m over 2 equals to negative 2m, and obviously that means m equals to 0. If you put m equals to 12 into here, you get n over 3 equals to negative 30, so n equals to negative 90. So there are two possibilities. Mn would take either 0 or 12 times negative 90, which is negative 1080. So obviously the smaller value is negative 1080. Hooray! And so for many of you, that's one question, right? I'm also aware for many of you, there's one question not right because of making some inadvertent error. Okay, let's continue. I think people are streaming in, which is nice. Realizing that it's not at 3 o'clock, but not to worry. If you're just joining in, you can watch the replay later. Of the front part was just a little bit of the usual intro. And yeah, this is just question 1, so you haven't missed too much yet. Question 2, another classic. So for the SMO Senior, SMO Open, right, you can sort of think that if you are someone who's well prepared, the competition is kind of spotting you 5 points at the start. There are about 5 questions that you should be able to do without like extra creativity involved. And so these are the sort of questions that are like that. Which of the following is true? You have a 6th root, a cube root, and a square root, and it's the same 3 numbers being permuted around. So the easiest way to do it is to take 6 powers of everything. So if you take 6 powers, the 6th power of 1 over 333, the 6th root of that is just 1 over 333. The 6th power of the cube root of 1 over 18 becomes 1 over 18 squared. And 18 squared is 324. The last one is the 6th power of square root 1 over 7. So square root is power half to the power of 6, then gives you a cube. So it's 1 over 7 cubed. And 7 cubed is 343. If you're unhappy with having to square 18 and cube 7, I think there's a lot more trouble coming for you. So let's just accept this, and now we can compare it. The smallest is clearly 1 over 343, followed by 1 over 333, and then 1 over 324. Okay, so we just need to remember which one they come from. It comes from the 1 over 7, 1 over 333, and 1 over 18. So answer is option D. If I'm being honest, I haven't read the open question 22 yet, so I'm going to be scrambling to do it after this stream, so I can't comment on that. I seriously have not read the question yet. I just have a copy of the paper with me and only scan through the first few problems. Since I'm going through the senior paper first, that's what we are doing here. Okay, question 3. Yeah, I understand there was that errata that was highlighted during your paper, where the 377 was mistake and it's 337. So nobody's surprised looking at all the multiple choice options anyway. Now, for all of these kinds of questions, usually you can just use a change of base. It almost always works that way. Right? So you can use a change of base for the thing inside. And I'll just use base 337. I mean, what am I doing? I don't have to change base for that. That is already log base 337. Now notice I'm not saying anything like, oh, 2022 is actually 6 times 337, so I can split it open. There's no need for that because the entire list of options in the question is all in terms of 337 and there's no 6. And the right hand side also has 2022. So I see no reason to destroy that symmetry. Now indeed, this becomes just this denominator is half, while the other two are both log 337 of 2022. Yeah, so this is 2 in the denominator. So you would get log 337 of 2022 times 1 over root 2. Now I want to make this into log base k of 2022. So I will just put them together now and divide this over so that I can do a change of base again. So 1 over root 2 equals to log base k of 2022 over log base 337 of 2022, which is log base 337 of k. I feel like I've written something wrongly. It's not 337 to the 1 over 2. Did I write something wrongly? Let me check. Okay, give me a second. Okay, sorry. Yeah, about the audio issue and the visual, just try to adjust your video quality if you need to. Should work out. Oh yeah, I am mixing things up. Sorry. Okay, so I was looking at the chat and then after I started writing something blindly and not realizing what I was doing. Yeah, that's not correct yet, right? I need to reciprocal both of them first before I can do the change of base. That's what happened. Right, so 1 over log 337 of 2022, you can flip the order first. Yeah, that's what I wanted to do and I lost track of things a little bit. Okay, so 1 over root 2 equals to log base k of 337 square root 2. Yeah, so I think I've inadvertently lengthened my solution more than I intended it to. But yeah, k is 337 to the power of square root 2. Yeah, thought I found a way to shorten it, but I think I've made my job a little harder. Okay, so let's move on to question 4. Suppose that y equals to cosine squared x minus 7 cosine x plus 25, where x is any real number, find the range of y. Now when you see a question that is entirely based on one trigo expression, then it's not a trigo question. The same thing applies to question 9 in a little while. Right? When you see a question where it involves a little bit of trigo, then it is a trigo question. When you see a question where the entire function or the entire expression is defined in terms of trigo, that's just a way where they wanted to shoehorn in something like this. Because the only thing you need to know about cosine is that cosine is between -1 and 1. But other than that, this is just no different from if I have y as a function of something else. Like let's say z squared minus 7z plus 25. Right, where we are essentially doing a substitution away. So just remember that if you are new to trigonometry, well, these are not trigonometry questions. So I'll just complete the square here. In a way, I'll just complete the square down here. this is 12.75. The reason why I say in a way I'm just going to complete the square here is that you realize that from -1 to 1, they're all on the same branch of your quadratic graph. So if they're all on the same branch of the quadratic graph, it means the maximum and minimum values are going to just be at -1 and 1. You're never going to actually have z equals to 7 over 2. So since that can never happen, you just need to sub in -1 and 1. So if z is equal to 1, then I don't like to sub it into completing the square form. I just sub it into the original form and that's good enough. So at 1 it will be 19, and at -1 it would be 33. Okay, so the range is 19 to 33. So that's good enough. And yeah, it is from 19 to 33. Since they're all in the same branch, we don't need to worry about whether there is a minimum or maximum in between. Okay, finally, for the multiple choice, we have question 5, which is again a classic in SMO terms. This is really a trigo question, but it is not a very difficult trigo question. Now, the first thing to note is that sine 180 degrees plus x can be shifted back to sine x very easily. Right? It's just going to be positive 7 over 9. And then you need cosine. Now, this is the second quadrant. So in the second quadrant, we know that the cosine should be negative. So it's the negative square root of 1 minus sine squared x. And just put it in. And this is what you will get for cosine x. Now, 4 of the 5 options include a square root 2, so we are not too surprised to see square root 2 over there. Another thing is that in the options, you see negatives appearing, and the same expression appearing without the negative. So this is sort of a warning sign. When you see this in a multiple choice, just please double check the signs, no pun intended, whether they're supposed to be positive or negative. So sine 2x equals to 2 sine x cos x. And we just put these in. Right, so we get negative 56 over 81 square root 2. Okay, so that's the multiple choice, and we shall do probably up to question 8 or 9 before taking a quick breather. Maybe question 10, we'll see. Okay. Now, question 6. The key insight for question 6 is that it is question 6. It is not supposed to be very difficult. Right? When you hit the start of the short answer question section, it is not supposed to be very difficult, meaning that if you have a very complicated approach, then yeah, it's not quite right. So in a sense, some of you have seen my other videos, I talked about wishful thinking, right? Wishful thinking is that what is the best possible thing that could happen to such a question? And give it about 30 seconds worth of space. Can the best possible thing happen for this question? If it does, you have solved the question in 30 seconds. If it does not, we have only wasted 30 seconds. Right? So start by assuming the question has some really cheap gimmick. If it's there, at least you spotted it. If it's not there, you only just spend 20 seconds to not spot a non-existent cheap gimmick. Now here the gimmick is that these two are just negatives of each other, right? Cosine 110 is equal to negative cosine 70. And so cosine 70 cancels off, and you're left with just cosine 10 plus cosine 50. Now, you're left with cosine 10 plus cosine 50 over cosine 20. And since there is cosine 10 and cosine 50 at the top, we shall just use a sum to product. Now, 10 is 30 minus 20, 50 is 30 plus 20. So cosine plus cosine would give you 2 cosine 20 cosine 30, which is just what we want. Okay, so your cosine 30 degrees is root 3 over 2, so it is just square root 3 cosine 20 degrees. And so our answer is nothing more than the 8th power of square root 3, which is 3 to the power of 4, and that is 81. Bit of surprise here if you didn't get it, but yeah, I said the main hint is that it's a question 6. It's not supposed to be very difficult. Okay, question 7. Suppose that, another common SMO tip. The moment the equation just makes you stop and say, what is that? It's probably a very easy question as well, because there must be another simple gimmick. Now, think of this from the perspective of weighted, like for chemistry, right? You have some things that can mix and some things that cannot mix. Now in math, when you have different types of functions, they just don't mix. For example, if you have a polynomial with an exponential, they generally don't mix. If you have trigo with a logarithm, they generally don't mix. Now I say generally, you know the full context. If you integrate some trigo thing, you could get a ln, but most of the time they don't mix. So if they don't mix, you want to handle them separately. And furthermore, you see 20 and 10. So that gives the impression that it is x to the 10 squared is x to the 20. So accordingly, let's just separate out the part which is polynomial from the exponential part. And hopefully you can realize that this is actually a perfect square. And this is also a square. Yeah, I know 3 to the x over 3 looks a bit weird, but yeah, it's just in order to make it, keep it as it was. Now everything here is going to be positive, so I can just get rid of the squares, don't have to worry about negatives. And we need 12x to the 10, 4 times 3 to the x, so just multiply by 12. So 4 times 3 to the x minus 12x to the 10 is equal to 3. Now, what's the value of x? I have no idea what's the value of x. It is probably just going to be some random irrational number, but does not matter. It is very unlikely that the value of x for such an equation would be nice. So we don't need to care about what it is, we just need to care about precisely the thing they asked us to find. Now I see that there are many of you here from the open side as well. I'll see you later, hopefully. There are many of you here who are eminently overqualified to be down here and can probably be doing this as well. What you guys want, I suggest is just, as you're joining in, just take a look at like how I'm explaining it and take some pointers from what you think is good, and also look for some ways in which you think you could explain it better. Right now, I'm doing this semi as a live explanation. I've this is obviously the first time I'm explaining this, so it's not very refined. It's just how I think I would approach it. If you think you have a better way, do that. Especially for the many of you who are involved in SMO team, you're involved in your school's math club, math Olympiad training, math interest group, whatever it is, right? If you're doing training for your students, right? How do we actually go about explaining stuff like this? Don't think of it as teachers are just in a different league altogether. Now, it's just solving this the same way as I would like a student, except with a few more years of experience of talking about it out loud. So take away some pointers if, let's say, you are one of those who are extremely overqualified for being here. Alright, question 8. How many positive integers less than or equal to 2022 cannot be expressed as floor 2x plus 1 plus floor 5x plus 1? Now, let's just try. I will start by noting that I can take out the 1 from the inside of both, so I will just write it as floor 2x plus floor 5x plus 2. Right, the plus 1 is going to be coming out anyway. And now you have floor 2x plus floor 5x. The idea is that I want to think of it as, well, the floor function is sometimes called the step function. And it's called a step function because if you draw the graph, it literally looks like a staircase. So think of it as, when does it take a step? And when does it skip a step? Now, if it skips a step, that is the time where it gives you something that you cannot express because it skipped over it. So at x equals to 0 is a pseudo starting point that will give me 2. And the question is, can I get 1? Answer to that question is no, I can't get 1 because if I go slightly below 0, both of these are going to hit minus 1 at the same time. Right? So I'm going to jump straight to 0 and there is no 1 in between. Right? If x equals to, let's say, negative 0.1 or negative epsilon. Now, as we continue on, each time when I go up by 0.2, this is going to click. When I go up by 0.5, this one's going to click. And I want to see which step it skips. Okay, so at 0.2, it is going to be one step. At 0.4, it takes the next step. At 0.5, it takes a step for the 2x. At 0.6, it takes a step. At 0.8, it takes a step. And then at 1, it takes 2 steps. It skips a step. Right, so it jumps. And so you realize that the only time, in fact, when it jumps 2 steps and skips something over is when it hits an integer. Now, when it's an integer, if x equals to n, you would get 7n plus 2. Meaning that the one that you skipped over is 7n plus 1. Right? Because this is going to continue as you go from 1 to 2 and so on. So that means that we just need to count all of these. 1, 8, 15, all the numbers which are 1 mod 7. And that goes up to 2017. Right? So these are the ones that cannot be expressed. So let's just make sure we count this carefully. It's not worth that careless mistake after we've done the work. And it equates to 289. Okay, so question 9. If you were here as of about 15 minutes ago, you heard what I said about question 4. A question where you have only a trig expression and nothing else is not really a trig question. It is a trick question, if you will. Because tangent from negative 90 to 90 just takes on all real numbers. So you again can just substitute it away and let's use z again. So actually this is just nothing more than asking you to deal with a rational expression. It's not a trivial expression. So if you're racking your brains for trivial identities, just remember that those trivial identities are useful whenever you have like a blend of stuff. Like you have tangent x, then you have tangent 2x, and then you have sine x and cosine x. Now you can't just substitute it away, but the entire thing here is a function of tangent x, so you can substitute it away. Now, once we have this, the question is, how do we find the maximum possible value? And maybe you're racking your brains for all kinds of identities, this time algebraic stuff, or maybe AMGM or inequalities and all, but you're not seeing any. One option for some of you is, hey, let's just differentiate the whole thing. And I would say that it will work, assuming that you differentiate correctly and the critical points are nice, but there's no guarantee the critical points are going to be very nice, especially when it says find the maximum possible value of the square root of 33 times y minus 5. So it may not be very enjoyable to find the critical point. Now with that in mind, we're going to do something a lot more simple. Right? I'm just going to multiply this over and make this into another discriminant question. So I want to view this as a quadratic in Z and look for the values of y for which this quadratic has a real solution. So y minus 1z squared plus y plus 1z plus y minus square root 33 is equal to 0. This is the quadratic in terms of z. Right, so has a root z. Possibly roots, but has at least one root. And so the discriminant has to be greater than or equal to 0. So my friend who is trying to advertise his solutions in the chat, yes, I'm aware there is another channel that is also producing the solution, presumably yours, to the SMO problems, and good on you. So if anyone wants to watch that, please do. It's just for now the chat, just keep it clean for questions, please. Okay, so let's whoops. Alright. I think maybe I should not put all my SMO solutions in the same document, right? Then it keeps on trying to synchronize because there's too much stuff. Anyway, let's just expand this. And you get negative 3y squared plus, oops, my 4's in the wrong place, sorry. 4 should be outside, so thanks for that. Let me correct it. Now, as I'm writing, I'm actually checking here, right? And for these sorts of questions, you have to be very careful. If one sign or one coefficient goes wrong, you're going to be extremely unhappy about it because you'll be very perplexed by why your answer is so ugly, and you will need to just go back right to the start. So keep checking, is what I'm trying to say. Right, so this has to be greater than or equals to 0. Now when I'm trying to look for the solution to this, normally you would factorize, right? Well, I'm going to just negate the whole thing first. normally you would factorize, but here you have this very pesky square root 33 hanging around. And furthermore, you know that the square root 33 is supposed to be involved. Because if the square root 33 is supposed to be involved, otherwise how can this final answer be an integer? So I'm going to just now solve this by the quadratic formula, and so therefore again we have to recycle this whole quadratic stuff one more time. There's a way to do this without that, please let me know. Theoretically this can be factorized if you can deal with the square roots, but it is very hard to spot. So I think just going with the quadratic formula is the better choice. So just find the two roots. Yeah, so there's a little bit of gnarly stuff to do. Four times 3, 4 root 33 minus 1. Now I remember when I saw this, I was thinking that, okay, so if somehow this thing simplifies nicely, then we know we must be right. Because if this was not correct, then there's no way that it should simplify nicely. Now, thankfully it does. I am going to save you the time of doing that computation, because amazingly enough, the thing inside is actually 576 with no square root involved after you expand it, which is 24 squared. Right, so it did actually work out, and you want the maximum value, so we just take the plus. So the maximum y is 5 plus 2/3 square root 33. Yeah, and your answer when you put it back in here is going to be 22. Yeah, so look at how many lines of trigo we did. Nothing at all, right? Remember that the thing about SMO Senior is that they're trying to align it to a lot of your Year 3 and Year 4, Sec 3 and Sec 4 syllabus, and there was a huge chunk of stuff on quadratics. But quadratics alone are too simple for them to set more than one direct question. So there will end up being questions like this where they just want you to make one extra observation before you just solve it like a normal quadratics question. Okay, so question 10. Let's just do one more. For question 10, the good news is that it can be done in just a couple of lines if you know Ptolemy's theorem. The bad news is that if you don't know Ptolemy's theorem, it is pretty difficult to do this in a simple way. At least not that I know of. Maybe you can have some other tools to approach it, but I think those would be all quite a bit longer. Now, I'm drawing this in here. We know that it goes through the center, and we know that we get a bunch of right angles around because this is the diameter. But I'm actually not really going to use any of that. I'm just going to use Ptolemy's theorem directly, because in a square, I can let the side length be x, and the diameter be x square root 2. So, what does Ptolemy say? I'll write it out in terms of side lengths first. So for those of you who have not seen Ptolemy's before, this is for any cyclic quadrilateral, right? So if you have 4 points in a circle, I'm not using Q down here, right? So if you have 4 points in a circle, then you can do this. PS times WR plus PW times SR equals to PR times WS. Now this is a good idea because we get the WP plus WR, and everything else is either going to have a factor of x or is known in the question. So let's just put it all in. Right, you get x, SR and PS are both x, so x times exactly the thing we want is equal to x square root 2 times square root 20. Yeah, so it immediately collapses that the sum is square root 40. Yeah, about time management, right? Yeah, we're going to a break for a second, but just a note about time management. It depends on your target. Now, if let's say you are at the stage where you are running out of questions that you can solve, then even if you have to spend 10 to 15 minutes on a single question, it's worth it towards the later parts of your 2.5 hours. On the other hand, if let's say that you are able to solve a majority of the questions, you're just running short of time, then in that case it is worthwhile. If a question looks difficult and you say that, well, I could solve this, but I know my method will probably take 15 minutes, then just skip it first. At the end of the day, there are about 10 questions here that just have a very short solution, and there will be naturally about 10 questions that have a much longer solution and a few in between. So you have to just manage accordingly depending on what your natural pace is and what sort of target you have. Yeah. Alright, so we'll take a quick 5-minute breather and then we'll continue in a short while after that. Yes, and yes, you can use a special case for this to assume that W is any nice point whatsoever, including P or Q itself. Yes, you can do that. Assuming that W equals to P or W equals to Q is the kind of thing that you are very able to do for these sorts of round 1 questions. Okay, so we'll just take a quick breather. Alright, let us continue. Yeah, so as I said, I am still going through the senior question, so the open questions right now, and yeah, hopefully everything will be well prepared by that session. But let's stick to this first. Yeah, so we get this quite interesting geometry question. To be honest, I didn't see this setup before, so I thought it was pretty nice. Maybe it's more well known, I just didn't happen to chance upon it. But you have a quadrilateral with equal diagonals, and P and Q are midpoints. PQ and AC intersect at R, BD and AC intersect at S, and this angle PRC is 130 degrees. So find the angle DSC. Now as it turns out, the key idea is that this is actually going to, okay, not the key idea, the key conclusion is going to be that this triangle here in the middle is actually isosceles. And that's what will happen at the end. But of course, there's no reason why you should know that automatically. So I shall suggest a way in which we can deduce that. Because I did not know this beforehand. So it's not well known per se. Now, what I'm trying to do is to find some way in which this AC equals to BD can be made useful, and also some way in which the midpoints P and Q can be made useful. I tried to draw in some parallel lines, and I felt that didn't seem to help very much, right? If I construct, let's say, an extra midpoint here and get some parallel lines, it didn't seem to do that much. Now, if it works, then great. I didn't see how it would work, so I came up with a different approach. For a lot of geometry questions, unlike the algebraic problems, there's more than one variable approach, so it is okay if you have a completely different idea from mine. But the idea I had was to just using this midpoint here, I took triangle ADC and basically just reflected it, rotated it 180 degrees. Rotated it 180 degrees to form a parallelogram, because if I'm rotating it about the midpoint here, you get a parallelogram. So let me try to draw it such that it looks kind of like a parallelogram. Okay, that's not too bad. I want to highlight that by doing this, I have gotten myself an equal length. AC has been now moved over to, let's call this E, DE as well. Let's highlight it to make sure we know which are the equal lengths. So here we have AC, we have BD, and we have DE. Now I'm going to do the same thing about Q in order for this to be symmetric. So I'm going to take triangle DCB and also reflect it around like this. Again, my colors are here chosen such that it is actually those things that look equal are really equal. I'll call this point F. Now what happens is that because these equal length, so when I drew in these blue lines here, they are all of equal length and the same direction. So it means that we basically can get a third parallelogram at the bottom. So this is also a parallelogram. And so based on this, I can say that triangle DEB and triangle CAF are not just congruent, they are just translations of each other. Means that it's just shifted. And they are not just translations, they are also isosceles. So basically, this implies, if you can intuitively see it, you can already tell that this means this triangle here is going to be isosceles. If you can't intuitively see it, we can just do a little bit of angle chasing to verify it. Right, so this angle, because of the fact that we are just shifting it over, will be equal to this, and this is likewise also going to be equal to this. Okay, but basically we have two isosceles triangles and we are just translating it across. So it's still going to be isosceles. Okay, so therefore this is 130, so this is 50, this is 50, and this is 80. There's only one angle in the question, right? So for the most part, what you have to do is to figure out what is the relationship between all of the what's going on in the figure. It is not so much trying to figure out what is the significance of 130 degrees exactly, right? Because it's not a special angle. Yeah, so this figure is essentially set up by having two parallelograms with identical side lengths, and it tells you that this part in the center is going to also be isosceles. Okay, so continuing on to question 12 now. How many distinct terms are there if x squared plus y squared to the 11 times x to the 11 plus y to the 11 to the power of 9 is algebraically expanded and simplified? So this is kind of a meta question about the binomial theorem. So it is saying that if you did expand it, how would it look like? It doesn't ask you what does each specific term equate to, just roughly how does it look like. Now the answer to that is that since it's x squared and y squared and x to the 11 plus y to the 11, we know that the degree of all terms is going to be 2 times 11 plus 11 times 9, which is fixed. In other words, the only thing that we really need to worry about is just how many different powers of x can appear as a term. Or you can find out which ones cannot appear as well, right? That's also fine. I'm just going to present in terms of x first. Find all means find the number of possible powers of x. Now, based on the terms, there's x squared to the power of 11 and x to the 11 to the power of 9. It means that for each of the terms, it's very messy looking. The terms are all going to look like x to the 2n if you take n from the first one, and then x to the 11m if you take m from the second one. So you get 2n plus 11m, where the n is up to 11 and m is up to 9. almost everything can be formed here. We already can see that from this combination alone, you have got 12 times 10, which is 120 possible. But I need to find those that are repeated, which thankfully will not be that many, because the only way in which they can be repeated is if the different values of n can compensate for a different value of m. And the only way that that can happen is that if your n from being equal to 0 went up to 11. So this term increased by a multiple of 11, which is 22, and m reduced by 2. So it could be m, let's say here is 2 and is 0. It could be m is 3, here is 1. All the way to m is 9 and m is 7. So there are these 8 possibilities for n equals to 0 versus 11. These 8 combinations of m where the same power of x is going to appear with 2 different n and m. And so out of this 120, we remove those 8, leaving 112. About protractors. This is one of those things that since my time as a student has never ever been properly administered. So my suggestion is always, in practical terms, I'm not sure whether it's actually allowed. So just bring it. There's no harm in bringing it along. And if let's say your teachers tell you don't use it, then don't use it. Right? I mean, it is not clear whether it's allowed. If you look at the rules, it doesn't mention it. But at some other point, I recall a mention of do not use any geometrical instruments or things like that. So it's a bit odd. Whether it is allowed or not seems to be still ambiguous up to this point. Yeah, but for drawing purposes, if you can't bring in a compass, bring in something circular, small container or something. They can't remove if you have a small round container, right? So if you want to draw straight lines and draw circles, you can. It's just for a protractor, it's a bit iffy. I'm still not sure what is the general protocol, and it hasn't been very consistently implemented. Okay, question 13. Now we are starting to get to more of these kinds of problems where you might start asking, why didn't I think of that? And the answer is not so much that you didn't think of that, but you thought of something else. And what you thought of is not silly, it just did not work for this question. Now for many of the SMO senior and open questions, you need to possibly go through 2 or 3 reasonable candidates before you get to the correct solution. For example, in question 13, what are the reasonable candidates? You might think of a substitution. But didn't quite work that well. You might think of squaring the whole thing. And it also doesn't seem to work that well. Now these are not unreasonable things to try. It just doesn't work that well for this particular question because they are looking for something else. And what they are looking for is using the idea that these expressions to the inside are related to x minus 1 in some way. Namely, that the difference is 8x minus 8. So 8x minus 8 is a multiple of x minus 1. Now, with that in mind, what I'm going to do is to multiply in the conjugate. And the conjugate here, as I said, is with the intention of cancelling out the x minus 1. So this here, using the properties of the conjugate we have just mentioned, is going to give you 8x minus 8, which is 8 times x minus 1. Sorry about this. So clearly it's not saying that the solution to this is x equals to 1, right? X equals to 1 doesn't work. So we can cancel this off, and we are left with a simpler equation where instead of it being equal to x minus 1, is equal to 8. So square both sides and things will start cancelling out. Okay, so again, just move everything around. And what you will get at the end of this should convince you that we have done things correctly, right? Because 3x squared plus 14x is organically going to show up. So 3x squared plus 14x is equal to 65. Yeah, so I mean for the SMO questions, right? You do have to have multiple ideas in mind. That's one thing. And also you want to be able to over time get a bit more intuition for which of those ideas to test first. Now you wouldn't really get it right all the time. Let's say for me in some of these questions, the first thing I tried gave a solution. Maybe someone else tried a different thing and it also gave a solution. There are other questions where the first thing I tried did not give me a solution, the second thing did not give me a solution, and probably only the third or fourth thing did. But obviously, we are not going to repeatedly use the correct method on the first try for every single question. That's really unlikely. So try different things, and if it works out, great. If it doesn't work, try the next thing. But the more questions you do, the more likely you are to settle on the correct approach in the first or second attempt. Right, question 14. k equals to -1 plus square root of 2022 to the 1/5 minus 1, and let fx equals to k squared plus 2k plus 2 to the 10x. Find the value of log base 2022 of f of 2022. Now, my intuition for this, in fact, was humorously, without even having seen this part yet, I would like to simplify k first. In other words, I want to simplify this equation because that is a very weird value to be holding on to. 2022 to the 1/5 minus 1 square rooted minus 1 is just very odd. So if we simplify it and square both sides, and we add 1, miraculously it turns out to be the thing inside the fx. And so fx is precisely this thing, 2022 to the 1/5 times 10x, which is 2022 to the 2x. Yep, and so your answer is log base 2022 of 2022 to the 4044, which is just 4044. Question 15. Find the smallest odd integer n where n is greater than 2022 such that when 1808, 2022 and n are each divided by a positive integer p where p is greater than 1, they all leave the same remainder. I think this is easiest to write in terms of modular arithmetic because the first two numbers are known. So we are trying to say that 1808 is congruent to 2022 mod p. So subtract it over. 214 is congruent to 0 mod p. And so it means that p divides 214. Right? That's what it means by congruent to 0. Now, good news for us is that this is not very divisible by many things. This is nothing more than 2 times 107. And so p can only really be 107 if you want to have something odd. So if n is odd, it means that 1808 and 2022 are also supposed to be congruent to n mod p, and they can't be congruent if p were even. And p is greater than 1, so p equals to 107. That's the only thing that could happen. Then it's pretty clear that since n is greater than 2022, the smallest odd integer n is just adding on the 107 to get 2129. Okay, question 16. Now, I alluded to this in my junior stream yesterday that for this question here, can can be solved by using the Cauchy-Schwarz inequality, and that's probably the easiest way to do it as well. Now, the reason why Cauchy-Schwarz is going to work here is that what Cauchy-Schwarz does is to combine things term by term in a multiplicative way. So 12 over x and x multiply to 12. And 48 over y and y multiply to 48. So this is nice because by Cauchy-Schwarz, you just have to take the geometric means of 12 over x and x, the geometric means of 48 over y and y. And it would be square root 12 plus square root 48 squared. This is exactly what Cauchy-Schwarz gives you. This is square root 48 being 2 square root 12 is just 3 square root 12 squared, which is equal to 108. And this is 1. So it tells you that x plus y is indeed going to be greater than or equals to 108. Now, more or less, at this point, you can kind of just take the answer already, that it should be 108. But if you want to find out just to be sure what they are, we also can. And if we want to find out what they are, the equality happens when they are proportional. So 12 over x is to x is equal to 48 over y is to y. Okay, so if we just solve this, we are going to get y equals to 2x as the equality case. And y equals to 2x would work if y is 36, y is 72, x is 36, it will work. Okay, it would give you here 1/3 plus 2/3 equals to 1. So this is a valid equality case, and so 108 is really correct. Now, for many of these questions, again, yeah, you can possibly guess it. It is, however, pretty difficult to consistently guess correctly. So across a lot of questions that you guess, you may guess one or two of them right, but it pays to actually understand how to do them for each of these problems, because even if you guess one question right, it's pretty likely that a lot of other people will also guess one question right, maybe a different question, but it all balances out. So no huge benefit there from guessing too many questions. Okay, question 17. Find the largest value of 40x plus 60y if x minus y is less than or equals to 2, 5x plus y is greater than or equals to 5, and 5x plus 3y is less than or equal to 15. Now, the way I would do this is just graphically, to be honest, because the x minus y is less than or equals to 2, 5x plus y is greater than or equals to 5, and 5x plus 3y is less than or equals to 15 are just a little bit, random conditions. So I think it is much better if we simply draw a graph and take note of what regions these parts fall into. So firstly, x minus y is less than or equals to 2. So we draw the graph of y equals to x minus 2. this will be gradient 1, intercept -2. So something like this. Not drawing to scale really, we just need to know roughly how the shape looks like and to note the intersections later on. And it's supposed to be y is greater than or equal to x minus 2. So I will just I'll just point here so that we know it is that side of the plane. You can draw the other two as well. Y is greater than or equals to 5 minus 5x means that the gradient is -5, and when x equals to 0, y is 5. So the intercept will be here, and it's going to be something like this. Okay, y is greater, so it's going to be this part. Yeah, finally, this one would be y is less than or equals to 5 minus 5 over 3x. So there'll also be the intercept at 5, but this time the gradient is going to be smaller. So it would be something like this. Okay, so these are our three graphs. It's not really to scale, but I just needed to recognize, okay, it's a triangular region that roughly looks like this. Okay, yeah, maybe I should make it look at least a little bit steeper because the gradient is supposed to be more than 1, right? So if it's more than 1, it should at least be a bit more like that, maybe. So yeah, just do something like this. Y is less than or equal to. So basically, it means that the region we're referring to is the triangular portion down here. This is the part that we're allowed to take from. Yeah, linear programming. So 40x plus 60y, you want to find out the maximum. I like to think of it this way. 40x plus 60y, you can factor out a 20. And so if you want to maximize 2x plus 3y, and let's say that it's equal to k. Now that means that this is going to be a point on the line y equals to -2/3 x plus 1/3 k. I really should be shifting this out, right? I think there's too many questions and too much stuff in here. -2/3 x plus 1/3 k. Now -2/3 x plus 1/3 k. K is the intercept. So you want to get a point that is as high as possible. Now if you want to get a point that is as high as possible, on this, you just shift up a line, effectively. Right, you essentially just have a line, and you just imagine yourself shifting it upwards. And you want to get the point that intersects the region at the highest point, which in this case is really obvious. It's just the one that goes through that point at 5, 0. So it's still there. It's still this one. After all that work, it is the most obvious point in the whole thing, which is x equals to 0, y equals to 5. Yeah, but that is going to be the largest value. So the answer, which turns out to have been, again, more than moderately guessable, is 300. Right. And we'll do one more before our second break. This one more is actually a question that was exactly from last year. They just changed one number. I think it was question 6 or 7. Question 7, right? Yeah, it was question 7 from last year. So I'm aware some of you just happened to see the review of the SMO Senior the night before. I was looking at the stats, and I saw a lot of people doing very, very last minute studying. So if that's the case, then you would have seen the solution. Right, this is Q7 almost. So the solution I'm going to give is still exactly the same. I'm not going to be able to change anything. I'll just use exactly what we did the last year and do it again. Yeah, I feel like the SMO always wants to try to reward people a little bit for effort. So it is still a good idea to review the paper, just in case almost exact repeat of the question shows up again. And you get 1 free mark. Yeah, so what we did last year was to do a sum to product on both equations. Right, so the first equation would be 2 sine x plus y over 2 sine y minus x over 2 is equal to 1/2. And the second equation would be 2 cosine x plus y over 2 sine x minus y over 2 is equal to negative 1/3. Okay, I'm going to just write it in the same direction, right? So the x minus y over 2, y minus x over 2, just to avoid any confusion, I'll just put the one on top at x minus y over 2 and put a negative in front. Right, a bit more familiar in how it's normally written. So if we want to get sine x plus y, we really just need to extract anything out of here. So what I did the last time, and I'll do again, is to just square both of them and add it up. Now, when you square both of them, the reason why I want to square them is that the sine squared plus cosine squared is going to get dug out, essentially. So you're just going to be left with 4 sine squared x minus y over 2 is equal to half squared plus 1/3 squared. I think I should. Okay, so sine squared x minus y over 2 is 13 over 144. Now what we want is sine x plus y. So I'm going to just multiply. So negative 4 sine x plus y over 2 cosine x plus y over 2. Times sine squared x minus y over 2, which is the thing we've just found, is equal to negative 1/6. Now, the reason why I like this product is because sine x plus y can be written as 2 sine x plus y over 2 cosine x plus y over 2. I really need to take a break and sort this thing out. So I'll finish this and we'll take a few minutes for me to also sort out some technical gremlins. Okay, so substitute everything in. This is 13 over 144. this is negative 2 times of what we want. And so sine x plus y is 12 over 13. Giving you the answer of 25. Alright, so we'll take another quick break here, and then for the last 7 questions, we'll get to that in the remaining time afterwards. So we should finish slightly before 5 o'clock, which is, I think, relatively okay. So I'll just sort out some of this here. Hopefully the lag will improve a little bit and it'll stop refreshing so often in the middle of my solution. Right, welcome back. Let's do the last 7 problems for this paper. Interestingly enough, they don't really feel like they were in ascending order of difficulty necessarily. So some of the questions at the back are actually not very difficult. It has a little bit of difference from recent years in that for the past few years, the last few questions were just like, all the combinatorics, number theory, geometry questions were flushed to the back. This time not really, they just put some more questions at the back and they weren't actually much more difficult than the ones at the front. So that's just something to take note of when you are trying out these papers, whether in practice or if you just took it. You can start going in order, but as soon as you get stuck, just flip around and you may find some questions at the back that are not very difficult. Another thing, just the usual YouTube routine. Please like this video, please subscribe, and please join me for the SMO Open stream later, especially if you did take the Open, or if you will be only able to take the Open next year, if you will no longer be eligible for senior. Right, so let's begin. Question 19. For some positive integer n, the number n cubed minus 3n squared plus 3n has a units digit of 6. So this is to do with last digit, and because it is the last digit, technically you can do nothing more than try out all the possible last digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and see which one ends in 6. That would actually give you the answer as well. But there is also a kind of a hint in the next part when it says the product of the last 2 digits of the number 7n minus 1 to the power of 12 plus 1. That's somewhat of a hint because of the n minus 1 being mentioned below. And you realize that this here is just n minus 1 cubed plus 1. So this is just n minus 1 cubed plus 1 has a last digit of 6. We can say 6 mod 10. And so therefore, it means that the last digit of n minus 1 is 5. N minus 1 cubed is congruent to 5, and so n minus 1 itself is congruent to 5 mod 10. We don't need to get back n, right? Because n minus 1 is the only thing that matters. And we do know that the last 2 digits of powers of 5 are always 25. Right? The last 2 digits of 5 to the n, where n is more than 1, are always going to be 25. So therefore, if n minus 1 has a last digit of 5, then n minus 1 to the power of 12, the last 2 digits will be 25. So just 7 times 25 plus 1 is 176. Last 2 digits are 7 and 6, so 7 times 6 is 42. Yeah, this is definitely not the 19th question in terms of difficulty. Right? It's just that it's one of the first few actual so-called number theory questions that's shown up. So guess place down here. Question 20, another number theory question of sorts. Find the largest positive integer n for which 20n plus 2020 over 3n minus 6 is a positive integer. Yeah, sometimes we can do long division and that will be fine. Here it is a little bit less appealing because 3n minus 6 is not going to be evenly divisible into the 20n. And you can take out a little bit, but it doesn't do that much. So I think I'll leave it here. Now what I'll do instead is to just look at the 3n minus 6 as 3n minus 2. So the first condition is that 3 must divide 20n plus 2020. Right, so I can divide by 20. And this would give me n is 1 mod 3. Great, so n is 1 modulo 3 will satisfy the 3 portion, and then we have the n minus 2 portion. Now, for the n minus 2 portion, the important thing to realize now is that if n is 1 mod 3, 3 and n minus 2 are coprime. So if they're coprime, I've already made sure that 3 is a divisor. Now I just need n minus 2 to be a divisor. And for that one, I can actually do the division. The division, the only thing that comes out of it is 20. And the remainder is 2060. Incidentally, the remainder is the thing you get from the remainder theorem. So if you don't want to write long division, you just sub in n equals to 2 and you get 2060 at the top. So 20 plus 2060 over n minus 2 is an integer. Means that this has to be a positive integer. And what bigger value can you get than n equals to 2062? Right, that's the maximum. When n minus 2 is literally equal to 2060, n is equal to 2062, and that is also 1 modulo 3. So 1 modulo 3 is satisfied. So this must be the correct answer. Question 21. In the xy coordinate system, there are two circles passing through the point 11, 3 root 3, and each of these circles is tangent to both the x-axis and the line y equals to square root 3x. This is a little bit odd, right? Now, let S be the sum of the radii of the two circles, find square root 3s. I don't think I want to worry about that. First, I want to worry about how does this thing even look like before we get there. So I'll draw it here. I need to draw in this line first of y equals to square root 3x. And before that, I shall try to make my axis actually be horizontal and vertical. So y equals to square root 3x. Something like this. You've got a point 11, 3 root 3 somewhere down here. Probably much lower than that. Yeah, and what you want to do is to have two circles that pass through that point and are tangent to both the x-axis and this line that I have constructed. So there will be two of them. One of them maybe looks something like this. And then one of them maybe is a much bigger one. Right? Maybe something like this. Okay, that's not very realistic, but I'm not sure. And it doesn't really matter that much anyway. So we have to find something useful about the radii of these two circles. And in such questions, you just need to find any equation, really. It doesn't matter which one. As long as you can find some equation for the radius, you are fine. Now, immediately, one thing that I notice about this square root 3 here. Now, if the gradient is square root 3, it means that this angle here is 60 degrees. Right? Because tangent 60 degrees is square root 3. That means that the center of these two circles must lie on the angle bisector. Must lie on the angle bisector, which is going to be at a 30-degree angle. And 30-degree angle, it means that this time tangent 30 degrees is 1 over root 3. So the angle bisector would be the line y equals to 1 over root 3x instead of root 3x. That's where the center is located. So let's just mark down the centers. So what other information do we have? We know that the center must lie on this line, and we know that the center is now going to have this radius. The radius is just its y coordinate. And we need to make sure that that's equal to the distance to this special point 11, 3 root 3. Yeah, so that's the solution. Or rather, that's the equation from which we'll get our solution. But it is essentially the solution to the whole question. Once you recognize that this is the equation you can write down. So let's say that we call the point here, either point, I'll just label here, I'll call it x 1 over root 3x. Now that means that the radius is 1 over root 3x, and I need that distance to be equal to 1 over root 3x. So I'll use my distance formula. And say that this distance is supposed to be 1 over root 3x. Okay, so we can square both sides. Yeah, multiply everything by 3, and what we're going to do is expand very shortly after that. So for multiplying this by 3, I'm just going to move a square root 3 inside the square so that you will get rid of all those nasty square roots. And yeah, and now we expand everything. Okay, shift everything over. 3x squared minus 84x plus 444 equals to 0. Now, once we have this, we don't actually need to solve this equation. I mean, we can, but we don't need to. Now, we don't need to because we can say that from Vietas, the sum of roots to this equation is 28. Now, technically that's not, I mean, that turns out to be the answer. Technically that's not it. Because what we are saying is that the two possible radii are 1 over root 3x. So the sum of possible radii is 28 over square root 3. But you're multiplying by square root 3 back again, right? So it doesn't matter here. You still get back 28 again. And so we get it back in the end. Okay, 22. Another quadron question that is really geometry. This is a bit unusual for the SMO senior. Usually there's one such question, but here there's two in a row. But it's not a very difficult question. So let's draw the axis again. P is 20 times root 5 minus 1, 0. Q is 0, 10 square root 5 minus 1. Let R be the point AB. If PRQ is a right angle, find the maximum possible value of B. Now, for some of you here who are my students, I think I've actually set a very similar question to this for a mock paper we prepared. That one I asked about a locus, I think. But this one is just asking for a maximum value. Nonetheless, the idea is very similar. Now, one possible point, which is very clear, is going to be here, right? The origin is going to work, if that is R. But that is not going to be the maximum value. We need to ask ourselves, where else are you going to get a right angle? And the answer to that question is if we draw a circle. And for our circle, is a circle where PQ is the diameter of the circle. And PQ is the diameter, it means that you get an angle in a semicircle, which is 90 degrees. This looks more like a very squished shape. It looks more like an orange, but never mind. The center of this, which I'll call O, is 10 root 5 minus 1, 5 root 5 minus 1. It's just the midpoint. So you want the point on this circle with the largest possible y coordinate, and so literally just look up. Right? You go up, that's the maximum possible value of B. So I need to know what's the radius of this. Now, to avoid very messy computations, I just realized that since I want to know the radius, I just need to get half the length of PQ, or rather just the distance from O to Q or O to P. I think I'll just use the half the distance of the diameter because it is easier to write down. And the square root 5 minus 1 is a common factor, so I'll take that out. This would be 5 root 5 times root 5 minus 1, which is 25 minus 5 root 5. So that's the radius. And so the largest possible value of B would be, you start from the center and you go up, which is 5 root 5 minus 1. So the square root 5s cancel out, as they should, and you're left with the maximum value of B being 20. So when you're doing coordinate geometry, don't take leave of your geometry senses entirely. When you're doing geometry, consider the possibility of using coordinate geometry. Now, these two go hand in hand. Right? There are some questions where if you can't figure out how to do it so-called in a geometric way, you can just impose a set of coordinates and it becomes straightforward, affectionately known as coordinate bashing. Conversely, if you have a coordinate geometry question, you do need to sometimes use some geometric ideas, right? Such as angle in a semicircle is 90 degrees, so every other point R has to be on the same circle. Question 23. I found this a bit weird. It felt like this was almost like a retroactive decision to put this question in, because it doesn't look like it belongs at question 23. It looks more like a question 3. But hey, if you get a relatively easy question at question 23, no one's complaining. First of all, the thing that's weird is when it says do not satisfy the inequality. Or doesn't that just mean that it satisfies the opposite, which is just like this? So it's a weird way to describe just less than or equal to instead of a greater than. Right, so it's just saying how many n such that it is less than or equal to. And because they're positive integers, there isn't like a third possibility where something is undefined. Right? There's either greater or less than or equal to. There's no undefined to be worried about. It's not real numbers. Now this is n to the power of half. And since you're working with positive integers, we know that it is not going to be a case where n is negative or n is between 0 and 1, such that higher powers make it smaller. If n is greater than or equals to 1, we can just get rid of the n and say that 1/3 log 20n is less than or equal to half. So log 20n is less than or equals to 3/2. Yeah, I'm also just as mystified how this is at question 23. So n is less than or equal to 20 to the 3 halves. Yeah, this is probably the only thing where you need to do a bit of estimation. Right? 20 to the 3 halves is 20 root 20, which is 40 root 5. And you just need to estimate square root 5 to a couple of decimal places. Right, so this is the upper bound, it's somewhere about 89.2. So that's good enough because it means that n can go from 1 to 89. There's no other constraint here, so it's just really 1 to 89. Okay, question 24. Now, this is a functional equation. If you have been doing some practice, including my mock paper as well as some of the recent SMOs, you know there's usually one question on functional equations in the SMO senior, and that question is not going to be very difficult. The approach is just to substitute some values in, because this is a functional equation, and a functional equation is basically an identity. It's just like when we said sine squared x plus cosine squared x equals to 1. That means that I can put in any value of x. Well, any real value of x, although it does technically work for complex numbers as well. Any real value of x. You don't have to worry about why does it work? Because the question told you so. So if you want to find 1, the most obvious thing to do is to put in 1. So just let x equals to 1. You will get 3f1 plus f9 equals to 292. Well, we want to get 1 in a different way, so we can put in the value of x such that 13 minus 4x is 1, which is when x equals to 3. So that's the other substitution to do. And if you do the other substitution, you really get 9 and 1 again, leaving you with nothing more than a pair of simultaneous equations, which is not very difficult to solve. Okay, so how do we find f1? With these simultaneous equations, just add them, divide by 4. f1 plus f9 is 150. Yeah, and then just 292 minus 150 over 2. equals to 71. Calculation errors do happen now and then. So yeah, it's up to you. You know how careful or how non-careful you are, and you can allocate your time accordingly to verifying at the end or verifying after doing each question. Now for me, whenever I see a question, like let's say question 23 or 24, where the solution is actually quite straightforward, right? I mean, we can agree that objectively the solution is straightforward, then there isn't much to check. So we want to double check those kinds of problems, because if you make a calculation error, there isn't enough in the question that will give you a weird answer. If let's say for some of the earlier questions you did a calculation error in between, it's a very high likelihood that your final answer is just going to be gibberish. So it kind of self-checks a little bit. But when the question is like this, you don't have the benefit of such a self-check. So it is important to try to verify those couple of steps just to make sure you don't drop marks on a question like this and get very annoyed thereafter. Okay, finally question 25. I find question 25 pretty humorous because it's just the same thing as the MCQ question earlier on, right? It's actually the same as question 4. It's almost exactly the same thing. It is asking you for basically the maximum value of the left hand side, and it is just, again, in terms of, well, it's one step away this time. You just write it as 1 minus sine squared. I'm not a fan of basically repeating the same concept of a question, because it means that if you know how to do it, you get 2 marks. You don't know how to do it, you lose 2 marks for the same one idea. So I'm not such a big fan of it, but yeah, it is what it is. So you want to now find out the maximum possible value of this expression here. And you complete the square again. Right, so the maximum possible value is 9 over 8. And therefore, since the maximum possible value is 9 over 8, it means that your maximum possible m is going to be 999. Which is a pretty anticlimactic way to end, right? Because we were just getting into harder questions, and then suddenly the last 3 were quite easy. It felt like as if you ran out of ideas and put in 3 easy questions at the back. But again, this is a reason why you shouldn't assume that questions should be attempted in order. You get something like this at the back end, which is pretty achievable. Okay, now to address all the random questions on cutoffs everywhere, I don't know, but just to lay out for those of you who weren't in the junior stream or haven't fully clarified all of this stuff. The cutoffs for the honorable mention and bronze hardly ever change. It's usually honorable mention cuts off at somewhere about 6 or 7, bronze cuts off at somewhere about 9 or plus minus a bit. You would expect that every year the cutoff for round 2 is slightly higher than the cutoff for silver. So if the silver cutoff is, let's say, 12, then maybe the round 2 cutoff is 14. If the silver cutoff is 11, maybe the round 2 cutoff is about 13. It'll be somewhere around there. And if you are trying to get into the second round, that is where the goal cutoff will be determined. The goal cutoff is determined by the first round plus the second round. Now, in theory, it is possible that if, let's say, you got 25 for round 1, you solved everything. then you might not need anything from round 2 to get a gold. It's theoretically possible, but for the most part you will need to get something, right? Because getting 25 for round 1 is not a given for most of you guys. So however it goes, if let's say you do get into the second round and you're aiming for a gold, then round 2 is the thing that is more significant than just the first round. Yep, I hope this is useful, and also don't worry too much about exactly how you did, especially if you think you're getting the second round, or if you just dropped 1 mark here or 2 marks there. Don't stress too much about it. Yeah, and that's about all I have to say. So I'll just leave the stream up for a few more minutes in case anyone has any questions or discussion, and after that few minutes I will just end the session, right, so that I can get ready for the senior one in a little while. Okay, so yeah, thanks everyone for joining. Hope it was useful, and if you have taken the open or are interested, then see you in a couple of hours time.